Here we go with 8.1. I think this is going to be the most watched notes that we have because it's trig, and I think it'll be helpful to lots of students to rewatch this section. So 8.1 is an introduction to trigonometry. The reason we use trig is it's to help us to solve right triangles that aren't special triangles like we learned in chapter 3, or triangles that don't have, where we don't know two sides, so we can't use the Pythagorean theorem. So there's other ways now that we can solve for these triangles. First of all, it's going to be helpful to know some of the vocabulary that we're going to need. So the hypotenuse is going to be the side opposite the 90-degree angle, or the longest side of the right triangle, right here. The opposite side, we refer to it as the side opposite the reference angle. Now on this diagram right here, this angle right here is our reference angle, and it's denoted by theta. It's just a Greek letter that stands for angle, an unknown angle measure. The opposite side, if we go directly across from the angle, straight across, that's the side opposite the angle. And then the adjacent side is the one that's left over, is how I like to think of that. Or you can think of it as it touches the reference angle, but it's not the hypotenuse. And that's the adjacent side. We have a mnemonic saying, or memory aid, to help us remember these, some trig ratios that we're going to use. And it's SOHCAHTOA. Now the S right here stands for the sine ratio. I'm having a little lag here in my computer. Let's see if we can get it to catch up. Okay, maybe there we go. So S stands for the sine ratio. O stands for opposite. So we'll write that right here, opposite. And H right here stands for hypotenuse. And then we have C. That stands for cosine right here. And then A stands for adjacent. H again stands for hypotenuse. T stands for the tangent ratio. O is opposite. A is adjacent. Okay, now I know that as of right now you're wondering what all of these ratios mean. So let's get in and show you what the ratios mean. So sine, if we look up here at the SOHCAHTOA, sine stands for opposite over hypotenuse. So if we come down here and we look, sine is opposite over hypotenuse. Looking at this triangle over here to the right, it says to use B as our reference angle. So I always circle my reference angle. And I find the opposite side, so that's B, and my hypotenuse is C. So if I were to fill this in, I would say opposite is B over C for the sine ratio. Sorry, my camera is really lagging today, so hopefully we can unpause it for a minute, see if I can figure out what's going on with it. Okay, try again. So the cosine now of the same reference angle is going to be adjacent over hypotenuse. So that will be A over C. Write that right there. And the tangent ratio from reference angle B is going to be opposite over adjacent. So it will be B over A. Now these three down below here are just the reciprocal of the one above it. So this one we call the cosecant, and it is a reciprocal of the sine. So I'm just going, we sometimes call it the inverse too, but I'm going to just rewrite it as the reciprocal here. So if sine is B over C, cosecant is C over B. Okay, secant is the reciprocal of the cosine or the inverse relationship. So it is C over A. And then the cotangent goes along with tangent. That one makes the most sense, kind of sounds like it, tangent and cotangent. So it is A over B. Now remember, these are just fancy words that we use to explain a relationship between the lengths of the sides. It's like setting up a proportion of the sides. So if we come down here, number 1, this is supposed to say sine of r. And then it's supposed to say down here tangent of r. The notes got copied a little bit differently. So I'll just fill that in real quick. So the sine of r. R, when it says sine of r, that means I'm going to use r as my reference angle. So the sine is opposite over hypotenuse. So I'm going to write that as 18 over 30. And it's just like a fraction that I can reduce any other time. So I'm going to reduce that fraction. It's divisible by 3. So that makes it, 6 over 10. So it's divisible by, sorry, my brain's kind of cramping up right now. Let's see, what's the biggest? Let's go 6 over 10. We'll reduce that one more time. And it'll be 3/5. Okay, both of them were divisible by 6. Okay, the cosine of r is going to be adjacent over hypotenuse. So that's 24 over 30. And when I reduce that down, they're both divisible by 6 again, so it would be 4/5. And then the tangent is going to be opposite over adjacent. So 18 over 24, both divisible by 6, gives me 3/4. Okay, the other 3 ratios are, once again, they're the inverse, so we can do the reciprocal. So since the sine is 3/5, the cosecant is 5/3. Since the cosine is 4/5, the secant is 5/4. And since the tangent is 3/4, the cotangent is 4/3. Alright, number 2, this should also say tangent of S, cotangent of S down here. So sine of S, that means S is my reference angle. So I'm going to say opposite over hypotenuse. So 12 over 13. The cosine is going to be adjacent over hypotenuse, so 5 over 13. And then my tangent is opposite over adjacent, so 12 over 5. Cosecant is the reciprocal of the sine, so I'm going to call 13/12. The secant is the reciprocal of the cosine, so it's 13/5. And the cotangent is the reciprocal of the tangent, so it's 5/12. Okay, turn the page here. Okay, this top part was the part that was supposed to be printed on the other side that we just wrote in, so cross that out. Okay, number 3. Now this triangle right here only gives me 3 sides, so I need to find, or 2 sides, so I need to find the third. And if we use the Pythagorean theorem, since we know how to do that, I'm going to save us the work and say that it is 8. Here, after you use a squared plus b squared equals c squared. You need to recognize that. Anytime you have a right triangle and you have 2 sides, you need to recognize that it's the Pythagorean theorem that you're going to be using. So the sine of r, so r is my reference angle, circle it right here, is opposite over hypotenuse, so that's 8 over 10, and then I can reduce that down to 4/5. Okay, the cosine of r is going to be adjacent over hypotenuse, so that is going to give me 6 over 10, and I can reduce that down to 3/5. And the tangent of r is going to be opposite over adjacent, so 8 over 6, or 4/3 when I reduce it down. Once again, the other 3 ratios are just the reciprocal, so I have 5/4 here, I have 5/3 here, and I have 3/4 here. Alright, number 4. We should recognize this right off the bat by now that this is a 30, 60, 90 triangle. So, the side opposite the 60-degree angle is my long side. To find my short side, I have to divide this number by the square root of 3. If I have 2 square root of 3 and I divide that by square root of 3, I get just 2. So this length is 2. And then if we remember, the hypotenuse is always double the short leg. So this length is 4. Sine of S, that means S is my reference angle. So I have to go opposite over hypotenuse. So 2 square root of 3 over 4. And this reduces down. Remember, if it's inside the radical, I can't reduce it, I can't touch it, but whatever's outside I can. So 2/4 reduces to 1/2, or just square root of 3 over 2. I can put my 1 out here if I want, but it's just 1 times square root of 3, so I don't need to do that. The cosine is going to be adjacent over hypotenuse. That's an easy one. 2/4 or 1/2. And then the tangent is going to be opposite over adjacent. So 2 square root of 3 over 2, and that simplifies to just square root of 3, because my 2's right here will cancel. Okay, the cosecant is just going to be the reciprocal of the sine, so it's 2 over square root of 3. And then remember, I don't like to have a square root in the denominator, so I'm going to times by the square root of 3 over the square root of 3, and I get 2 square root of 3 over 3. And that's my answer. The secant, that's a little bit easier to flip upside down because it's 1/2, so that makes 2 over 1, or just 2. And then the cotangent would be 1 over square root of 3. So I have to times it by the square root of 3 over the square root of 3, and I get square root of 3 over 3. Okay, now as long as you know how to set up these ratios, that's as far as you need to be right now. Even if some of this doesn't quite make sense, you're not sure how you're going to use this, what we're asking right now is that you know how to set up these ratios. We're going to get into how we use this a little bit more into the next set of notes. So let's look at number 5. Talks about using special right triangles. See if I can get this to focus just a little bit better here.